alkanes is going to be the focus of this section. Hydrocarbons, remember, are compounds made of just hydrogen and carbon. They are the simplest organic compounds, and they are broken up into 4 different categories. So the first one we're going to look at is alkanes. You're going to recognize that you're dealing with an alkane because first of all, it's just a hydrocarbon, just carbon and hydrogens, and it has no multiple bonds. So in other words, it has only single bonds. Alkenes are hydrocarbons that have a double bond. Alkynes have a triple bond, and aromatics usually contain a benzene ring. Okay, so that's how we're going to identify our aromatic hydrocarbons. So benzene can be written a couple different ways. So you can show the benzene with these alternating double bonds. We haven't dealt with resonance structures in this class, so I don't want to delve too deep into this, but really these double bonds aren't just held in this exact position. So another way a chemist will show benzene is to put a circle in the middle, indicating that those double bonds really are shared equally among that whole ring. So just be able to identify either one of these structures as benzene, because that's how you will identify your aromatic hydrocarbons. Okay, this particular lecture is going to focus just on alkanes. Alkanes are hydrocarbons with no multiple bonds. Notice that the shape of the molecule around each carbon makes 4 covalent bonds and is tetrahedral. So remember that when we were dealing with, let's look down here at the Lewis dot structure. Carbon in the middle, it has 4 different electron clouds and 4 different atoms. So this would have a Vesper geometry that's tetrahedral and also a molecular shape that's tetrahedral. So all of your alkanes have a tetrahedral shape around the carbons. So if you remember, they have about 109-degree bond angle. I went ahead and put together a model kit for you. Not sure how well it's going to show up on the camera, but we're going to give this a try. A couple things to notice. So this is an alkane, and every carbon has a tetrahedral shape around it. So that might be hard to see, but what I do want you to notice is since it's tetrahedral, the shape that the carbons get into. Do you see that it's kind of a zigzag, up, down with the carbons? Why that's going to be important is because when we get to where we're drawing bigger molecules, and I want to simplify the big long chain that's just hydrocarbons, you're going to see me do a zigzag. And we do the zigzag to represent those carbons that are, have that tetrahedral shape. So there's our alkanes. Naming alkanes. So let's start off by looking at this first column here, which is the condensed structural formulas. So the simplest alkane just has 1 carbon. So it'll be surrounded by the 4 hydrogens, and the name of that molecule is called methane. This column here is the molecular formulas. You might want to actually write the word molecular on the top. So we have our first column is condensed structural formulas, and over here is the molecular formulas. And then the last column is the boiling points. In degrees Celsius is what that should be. So taking our simplest one carbon called methane, boils at negative 164 degrees Celsius. So a very low boiling point. The next hydrocarbon, the next simplest one, has 2 carbons, and the name of that is ethane, and this would be the molecular formula. And notice it still has a low boiling point, but it's higher than the methane. So if we were to look at the trend in our boiling points, the more carbons you have on your chain, the higher the boiling point is going to be. We talked about that a little bit in the last lecture when I was talking about how they separate petroleum, and they heat the petroleum, and they at different temperatures it boils off. And the lighter the molecule is, the less carbons, the lower the melting point is going to be. So a couple things I want you to know from this slide. First of all, we are going to go into naming alkanes. So I am going to expect you to be able to name alkanes up to 10 carbons. Okay. And I want you to know boiling point increases as the number of carbons increase. We'll talk a little bit more about naming in a little bit here. And then I do the physical properties. In inorganic chemistry, I'm going to take you through different groupings of organic molecules, and we call those different functional groups. And when I get to a new functional group, I'm going to not only talk about what type of reactions it does, but also some different properties. So if you are choosing to make note cards, you might want to have a note card on physical properties of all the different groups I talk about. So right now, focusing on alkanes, the physical properties is that alkanes are less dense than water, and they are insoluble in water. So I remember when I was a chemistry student, what helped me remember that was at the time, my teacher was telling me this, there was an oil spill where a tanker that was carrying the petroleum had hit an iceberg, and no, what did it do? I can't remember. There was some accident that caused the oil spill. And what happened was the oil made a layer on top of the ocean. And so that was an indication to me that it was less dense than water because it floated on top of the water. And it also didn't dissolve. It made two different layers. So that also helped me remember that, that alkanes are insoluble in water. So they made the two different layers. Okay, I put a copy of your information sheet into the lecture here because I wanted to point out some prefixes that are going to help us with naming alkanes. So I'm going to grab my pen. Here we go. So we have got, let me go back to the previous slide. The first four here have new prefixes that you haven't, or you might have heard before, but we haven't worked with them before. So I'm going to want you to know that meth means there is one carbon. The prefix eth means you've got two carbons. Prop means three carbons. Bute means four carbons. And then after that, the prefixes, if you look at them, they are the Greek prefixes that we used when we were naming covalent compounds. So I just wanted to point where the locations of those are on your information sheet. So we're giving you, methane is CH4, ethane here with two carbons, propane with three carbons, butane with four carbons. So we've basically given you the name of the first four. After that, you're just going to use your Greek prefixes for my pen, 5 through 10. And the prefix would start off here with, so 5 is penta, 6 is hexa. So if you've got a hydrocarbon that has 5 carbons, it's going to be pentane. And 6 carbons is going to be hexane, and then heptane. Okay? So naming hydrocarbons, we're giving you a little bit of help. Another thing to notice is how they all end. When you're dealing with alkanes, notice the last 3 letters. This is important, just like when we were in inorganic chemistry. And I wanted you to pay close attention to whether the molecule ended with IDE or ITE or ATE. When you're in organic chemistry, the last 3 letters are very important too. Having a hard time finding my pen. Okay. So I want you to memorize that alkanes, all of their names are going to end with ANE. It's another important part. Okay, so write the condensed formula for this structure, and then I want you to tell me the molecular formula and the name of this formula. So writing the condensed formula from a structural formula, you just start from left to right. So you start off by writing down the first carbon. So there's my first carbon, and then you write down how many hydrogens are bonded to that carbon. Well, if I look at this, I've got a hydrogen up, left, and bottom, so that's 3 hydrogens. And then I move to my next carbon. So I put that carbon down. And how many hydrogens are bonded to this carbon? 2. 1 above it and 1 below it. Then I move to the next carbon. And once again, there's 2 hydrogens on that carbon. And then I move to the next carbon and I have another CH2. And then when I move to the last carbon, that's a CH3. So your hydrocarbons are always going to, your chains are going to start off with CH3 and end with CH3. Another way you could have done this condensed structure is you could have put your CH2s together. So if I put my CH2s in a parenthesis and I look at this structure, how many CH2s do I have? I have 3 of them. And then I have my CH3. So either one of these are acceptable answers for a condensed structural formula. Molecular formula, all it does is tell us what atoms we have and how many. So if I count up my carbons, there's 5. And if I count up my hydrogens, I've got 6, 7, 8, 9, 10, 11, 12. So that's the molecular formula. Now, to name this molecule, the first thing we do is we count up our our carbons, excuse me. So we've got 5 carbons. You look at your information sheet, and the prefix for 5 is pent or penta. And I told you that alkanes always end with A and E. Now, we know this is an alkane because it's a hydrocarbon and it only has single bonds. So that's why it's going to end with A and E. And pent means it has the 5 carbons. So, some structures of butane. So remember, butane has got 4 carbons. You don't have to memorize that because we have it on the information sheet. So but is the prefix for 4 carbons. Ane means it's a hydrocarbon with all single bonds. So here is our simplest, well, here's the way we're going to write butane. So there's our 4 carbons. But I want you to notice something, and maybe let me first talk about it using my model here that I put together. Single bonds, the molecules can rotate around single bonds. So I can rotate this molecule around the single bond. So when I give this molecule heat, so if it's in a beaker and I start heating it up, it just starts spinning around itself. So notice you can get it into a bunch of different funky shapes by rotating it. Okay, so it's not always going to be that nice straight line for you. So you need to be able to look at how I have these other structures and be able to say it's butane. So you've got to get good at finding your longest continuous chain. So this one here is kind of obvious. We just got 4 carbons in a straight line. Here I've got 4 carbons in a row, but they're bent over. And now here I've got it totally kind of curved around itself. So you want to be able to look at all these and say, oh, all of these are just butane, just bent around itself, or written up straight up and down versus left to right. Here's the zigzaggy way. So here's what we're going to start doing when we get into bigger molecules, is just symbolizing a hydrocarbon chain by using the zigzag. Isomers. The definition of an isomer, they're the same organic molecule, but they're going to have different representations. So, for example, which of these following molecules is structurally different from the other? So 3 of these molecules are the exact same molecule, just bent around differently, and 1 of them is different. So pause the video and see if you can figure it out. What I recommend doing when you're given a condensed structural is I recommend actually putting it out in the structural. So let's start by taking this one that's condensed and writing it written out. So I'm starting off with my ch3. And then I move to a ch2 because it gets a little bit tricky down here. Then I move to this 3rd carbon, and what do I have bonded to this 3rd carbon? Well, it looks like I've got 3 ch3s. So we know carbon has to have 4 bonds, so I need to put 3 things on here. And my condensed structural formula is telling me there's 3 ch3s on this carbon. Okay, so let's look at these guys. This one right here, I've got 4 carbons in a row, and I have a branch off my 2nd carbon over and a branch off of the 3rd carbon over. When I look at this molecule, I've got 4 carbons in a row, but I have a branch coming off of the same carbon. So that's a little bit different than this one. Here, what is my longest carbon chain? Well, it looks like I can go this carbon to this carbon. So I've got 4 carbons in a row, and I have a branch, 2 branches coming off of the same carbon. If I look at this one, I've got 4 carbons in a row and a branch coming off the same carbon. So this one right here is the molecule that's different because it has 2, we call these methyl branches, but they're coming off of different carbons. All these guys have a methyl branch coming off of the same carbon. So we would say that these 3 molecules here are all the same. You're just looking at them from different angles or bent upon itself. But this particular molecule is an isomer of this molecule. Okay, so these 2 are isomers of each other. Isomers have the same molecular formula. So if we go back to the slide before, you're going to notice if you counted it up, they would all, the formula would be the same. So that's one of the first rules. Isomers have the same molecular formula, but they have a different arrangement. So isomers of butene are, if we look at the pictures here over on the right, we've got the straight chain where I've just got 4 carbons in a row, Or you can take it and you can put 3 carbons in a row and take that 4th carbon and have it branch off. So these 2 molecules are isomers of each other, but they both have the same molecular formula. Both of them have 4 carbons and 10 hydrogens, just bonded in a different arrangement. So know that definition of the word isomer. Isomers, it's interesting how many isomers you can get depending upon how many carbons you have. So you notice if you just have 1 carbon, then you're only going to have 1 isomer. There's no other way of doing the molecule with 1 carbon. The same is true if you've got 2 carbons or 3 carbons. No other way of getting a different isomer, so there's just 1 isomer for those. Butane, I just showed you on the previous page. It has 2 possible isomers. Pentane has 3 isomers. Now look what starts to happen. The more carbons you put on, when you go from 5 carbons up to 6, you go from 3 isomers up to 5. And then 7 carbons, you have 9 isomers. 8 carbons, 18. You add just 1 more carbon and now you can get 35 isomers. And look what happens when you get up to like 20 carbons or 30 carbons. That is why there are so many organic molecules out there, because carbon is just so versatile. There's a lot of different shapes you can do if you give me 30 carbons and 62 hydrogens. There's nothing from this slide I expect you to know for test purposes. It's an interesting trivia. I do want you to know, however, what isomers are and be able to identify them and draw them. So each structural isomer has a different name. So for example, there's 2 structural isomers of C4H10, each with a different name. So once again, isomers have the same molecular formula, but this one right here with the 4 carbons in a row is just going to be simple butane, because but is our prefix for 4 carbons. A-N-E means it's a hydrocarbon. This one right here has a special name. It's called isobutane. I'm going to stick to a naming system which is called the IUPAC. I don't know if I have this on a previous slide. So the naming system I'm going to teach you is the IUPAC naming system. And this one right here is more of a common name. Okay, so we're not going to use any of the isos, but this would be the IUPAC name. So if we look at it, our parent chain here is propane. Prop meaning the prefix for 3 carbons. So here is my 3 carbons in a row. So that's propane. But there's a branch coming off of it. And pretty soon I'm going to talk about how to name this branch, and this is a methyl branch, and it's on the 2nd carbon. So this molecule is 2-methylpropane. I know I haven't taught you naming, but the point I'm making here is that isomers are definitely different molecules. They have different melting points, boiling points, different names, things like that. When I was a student, I had a hard time seeing my isomers. So what I would do sometimes is I would actually just name them, and that would help me figure out which one was different from the rest. So the 1 carbon branch is called a methyl group. So I've kind of talked about that. So yeah, I have a slide coming up where I'll talk about it a little bit more. So alkyl groups. To name more complex molecules, we must learn how to name the branches. Branches are also called substituents. Okay, so naming the branches. What do I have? Alkyl groups are alkanes that are missing 1 hydrogen. So if we started off with, let me show you. Let me put down methane here, because methane we've talked about. Methane, meth means 1 carbon. And ANE means it's a hydrocarbon, so we're going to put on all these hydrogens. So this is methane. If I remove one of these hydrogens and bond it to something else, so that's what I'm showing you right here, is taking methane, but I'm taking off a hydrogen, hydrogen, and getting it ready to bond to a longer branch. Notice the ending changes. It still has meth, which means 1 carbon, but it changes to YLE instead of the ANE. So the ANE changes to YLE. So what that means is that this has now become a branch, and they call it an alkyl group or an alkyl branch. Eth is our prefix for 2 carbons. YL means it's a branch. So I've taken off a hydrogen off of the end of ethane and have gotten it ready to where it can bond onto something else. So that's how you're going to name your branches. So alkyl groups are substituents attached to a carbon chain. They're named by using the ending YLE. So here are some examples. These particular ones are unbranched alkyl groups. So they're alkyl groups that are just all in a straight chain. So this is what I just got done showing you. So methane with 1 carbon is going to change to methyl. Ethane with its 2 carbons will change to ethyl. Here's propane, which will go to propyl, and butane going to butyl. Notice all of these have got 1 less hydrogen, and the line that they're showing you here is indicating that it's about to move on to a bigger chained molecule. Okay, it'll be the branch off of one of the bigger chains. Some of your alkyl groups, the substituents or the branches, are branched themselves. And it starts to get a little bit more complicated there. In this class, I'm only going to teach you one of them. So there's only one branched that you need to learn about. And it's going to come from the propyl branch. So prop is our prefix for 3 carbons. A-N-E means it's a hydrocarbon. So here's propane. If I remove this hydrogen on the very end, and so it becomes a CH2, and this dash is where it bonds to the longer chain. This is just simply called propyl. Sometimes you'll see it with an N in front of it, N-propyl, but we won't be using the N. If, however, the hydrogen you remove is this middle hydrogen, and so the CH2 in the middle now becomes CH, and the bond to the longer hydrocarbon is from this middle carbon, then the name for this branch is called isopropyl. This is the one right here that messes up a lot of students. They forget this one. So make sure you asterisk it, put it on a note card, the difference between these two. Okay. Here I've got a picture to hopefully help kind of draw home the point. So this is my tree right here, which is going to be my longest carbon chain, which it's going to be called the parent chain. So the longest chain is like the trunk of our tree, and then we've got 2 branches coming off. This first branch down here on the bottom, find my pen, is just 3 carbons in a row, and it's branched off of my trunk on an end carbon. So that's just my N-propyl, or you can just call it propyl if you want. However, if you notice this branch is attached with my center carbon, which causes this branch to become branched itself. So I have a branched branch, and that's where we get the isopropyl. So make sure you keep those 2 straight. So naming the substituents. So in the IUPAC naming system, a carbon branch is named as an alkyl group. We just went over that. Halogen atoms are named as halo. So what this is saying is that if it's an alkyl group, if your branch just has hydrogens and carbons, you're going to change the ending to YLE. But if it's a halogen, do you remember what group the halogens are in? So the halogens are your elements in the 7A family. Okay? When you have a branch that is a halogen, you're not going to end it with YL, you're going to end it with an O. So here's a couple examples. Here is a branch that just has 1 carbon. It's a hydrocarbon, so it's going to be methyl, YL. This next one's a hydrocarbon with 2 carbons, so it's going to be an ethyl. Then we have propyl, and here's our branched branch, which is isopropyl. And then here's the halogens. So fluorine, chlorine, bromine, and iodine we're sometimes going to see as branches in our organic compounds. So when you go to name that branch, instead of ending it with YL, fluorine is going to change to fluoro, chlorine will change to chloro, bromine to bromo, iodine to iodo. So here are the rules for naming alkanes. The long word we use for naming is nomenclature. So the nomenclature we're going to use. This slide I know is wordy. What I'm going to do is I think I'm going to flip us back and forth between this slide and an example slide coming after so that I have something to work with while I'm teaching you this. Something to note though, some students like this. You do not have to know this, but here is the general formula for an alkane. So if I wanted, for example, to say, to do the molecular formula for a hydrocarbon that has 8 carbons, I could draw that out and I could put all my little hydrogens on to count them up, but the faster way to do that would be to know this formula, where if I'm trying to figure out how many hydrogens I want, I take N here is the number of carbons, so I take 2 times N, so 2 times 8 would be 16, and then I have to add 2 more to it, so I would get a C8 H18. So that's kind of a faster way of doing your molecular formulas for an alkane. But I won't ask you anything about that formula. Okay, so how to name an alkane. Here is the first step. Step number 1, find the longest continuous chain of carbon atoms, which we call the parent chain, and name it according to your basic alkane names, which I just kind of went over. And we have most of those on your information sheet. So let me skip ahead to this next slide so I can show you what we mean by that first step. The first step, actually, let's go ahead and do this bottom one together. Finding the longest chain. Well, if I start here on the left, if I go straight across, I get 3 carbons in a row. If I go to